You're welcome to another video of the course IPv6. In this section, I'm going to discuss and demonstrate IPv6 router advertisement preference, the other application of router advertisement message in neighbor discovery protocol, in which indicates priority of a router to be chosen as default gateway when there are more than one gateway in a single subnet. In the previous lessons, we have already learned some applications of router advertisement message, especially in the context of dynamic addressing assignment in IPv6 and the role of router advertisement flags, managed flag, other flags, and a flag in router advertisement message. In this section, we are going to learn the other application of router advertisement message, which is called router advertisement preference, a flag inside router advertisement message, which indicates the priority of a router, which by default is medium. That means when there are more than one gateway in a single subnet, all routers will send router advertisement, but all of them with the same preference, which is by default medium. And then client has to decide which router to be used as default gateway to forward the traffic of the client. With router advertisement preference, you are able to change the priority of the router to low or to high, so the clients can decide to choose the router with highest priority as the default gateway. And when the router with the highest priority fails, the next router with high priority will be as the next default gateway, something like a small version of gateway redundancy protocols like VRRP or HSRP. To better understand how IPv6 router advertisement preference flag in router advertisement message works, I prepared a topology, a subnet with a prefix 2001 AABBCC/64 with two gateways and one client. The IPv6 address of gateway 1 is set to 1, not only for global address, but also for the link local address FE801 as a link local address, and 2 for the second gateway. By default, router preference for both routers is medium, and the client should decide which gateway play the role of default gateway, which is usually the router which client receives the first router advertisement message will be chosen as the default gateway. Don't forget that the router starts to send router advertisement message when IPv6 unicast routing is activated in Cisco iOS router. Let's check the default behavior of router advertisement preference in the packet to start capture. To make routers to send router advertisement in the client, I will disable the interface and enable it again. In the client, IPv6 address autoconfig is already configured, which means the client is allowed to receive IPv6 address dynamically through a Slack method. So in the client, I will disable interface, shut down, and then no shutdown. And we can check the result of router advertisement message in Wireshark. And if we check inside the packet here in the flag, there is a flag with the name of default router preference. As you can see, it is medium by default. And the client receive router advertisement message from both gateway 1 and gateway 2, and based on this information, we'll obtain IPv6 address dynamically as we have discussed in the previous lesson. Just to check, in the client with the command show IPv6 interface brief, you see global IPv6 address and link local IPv6 address. If we check also show IPv6 route, we see that client has chosen the second gateway as the default gateway. Now I will change the priority of gateway 1 from medium to high to see the result of changing the preference. So in the router 1 and inside interface connected to the subnet with command IPv6 ND router advertisement with command router preference, we can change the router preference from medium to high. And then we will check again the result in the router advertisement message. The last router advertisement message, you see the preference has changed from medium to high. And we also check the result in the client side to see if the default gateway has changed or not. Default gateway has changed from the second gateway to the first gateway. And in the gateway, we can also change the interval in which router advertisement message is sent, which is by default 200 seconds, or in response to router solicitation message. With interval, we can change the interval to, for example, 4 seconds, the minimum. And here you can see that every 4 seconds, a new router advertisement message must be sent. You see, every 4 seconds. And now I change the interval to the default value with this command. And again, if you check, you cannot see router advertisement message quickly, and you have to wait until 200 seconds or in response to a router solicitation message. With command IPv6 NDRA suppress, you can suppress sending router advertisement message on this interface from the router, and therefore the client will receive router advertisement message only from the second router, and it is a simulation of failing the first router, and you have to see the result of gateway redundancy which exists natively in IPv6 protocol. However, a small version of VRRP or HSRP, we will suppress router advertisement message in this router, and then we will see again through IPv6 route, and you will see that default gateway immediately has changed from gateway 1 to gateway 2. This is actually the result of gateway redundancy protocol, which is natively exists in IPv6 protocol.